So one more time, on the moon where the acceleration due to gravity is only negative 1.6 meters per second squared, how far does the object fall in 5 seconds? So let's start with givens. What given information do we have here?
The time.
Yep, we've got the time it's falling for, and how long is that?
5 seconds.
Yeah. So we've got a time of 5 seconds.
There's a negative 1.6 for the acceleration.
We know the acceleration is negative 1.6. Yeah, it's a little better. Okay, what else? One more.
We got the initial velocity.
Yeah, we know the initial velocity, right? We know the VYI because it's starting from rest. We know the initial velocity. That's great. And then finally, the unknown. What are we trying to find here?
The distance.
The distance, right? How far it falls. So our delta Y. Good. Okay, and is the video with the paper on it, is that backwards for you guys, or is that, can you read that?
No, it's fine.
Okay, good. On my screen, it's backwards, but that's fine. Okay, great. So what equation should we use then?
The third one.
Which one? Sorry, Jose, I didn't hear you.
The third one.
Yeah, that's right. The third one, right? The third one, because that has these 4 symbols. It doesn't have the VYF. So it's going to be this one, right? Delta Y is our VYI times time plus 1/2 acceleration times time squared, right? So again, it looks like our unknown is already all by itself on one side of the equation. So for step 4, rearrange. We don't need to do that right now. We can go ahead and plug our numbers right in. All right, so VYI, that was 0. So 0 times anything is going to be 0, right? So VYI times delta T, that's going to just be 0. Plus 1/2, our acceleration is not negative 9.8 because we're on the moon this time, so it's negative 1.6 meters per second squared times 5 seconds, and that's squared. So I want to do 1/2, so that's 0.5 times negative 1.6 times 5 squared, and I get negative 20. So my delta Y is negative 20 meters, right? Because I've got seconds squared down here, and then a second squared in the numerator. So the seconds cancel out and just leave us with meters. And that's a good bit. If you remember on Friday, we had the same problem of the day, but we were on Earth with a bigger acceleration. And in the same 5 seconds on Earth, something would fall, I forget what it was, 120 meters or something like that. But on the moon with less gravity, it's only going to fall 20 meters in that time. Questions on the givens or the unknown or the plugging it in or anything on that one? I don't remember who exactly, but a few people got that one right the other day. That was good. Okay, let's take a quick look at the problem of the day for today. Give you a hint on that, and then we'll call it. So this is the problem of the day for today. I hope you can see it. It's on Schoology. It says a projectile is launched straight upwards with an initial speed of 35 meters per second, and we want to know how long it's in the air. So then it gives you a hint, though. You can assume that if it's moving upwards at 35 meters per second when it's launched, it'll be moving at 35 meters per second downwards as it lands. So that gives you a hint right there that it gives you not only the initial velocity, but the final velocity as well. You'll have both of those things. Okay, any questions or anybody want any hints or clarification on the today's problem of the day. Okay. Whoops. All right. Well, I guess that's all for today. Thanks for coming. Thanks for those of you that read. Hopefully tomorrow, we'll have a couple more people read and maybe a couple more people talking as well. It's kind of a quiet Monday morning. But thank you for coming. Thanks for showing up. And there we go. And I guess I'll see you tomorrow at 9 a.m. Remember to do the problem of the day.
All right.
Okay, Mr. Bye.
Bye, mister.
All right. Thanks for
Bye,
coming.
mister.
Have a good day. Bye-bye.
You too.